All right, today we're looking at lesson 11.1 and we're going to start with task 1. All right, so we're going to explore exponential growth functions. An exponential function can be expressed in the form f of x equals ab to the x power, where a and b are real numbers, with a not equal to 0, b greater than 1, and b not equal to 1. The parameter a is the value of f of x when x equals 0, and also the y-intercept. So a is the y-intercept, okay? All right, the parameter b is the base of the exponential function. If a is greater than 0 and b is greater than 1, then the function is referred to as exponential growth. All right. These are definitions that you definitely need to know, so make sure that you have those in your notes. Also, there's lots of little fine print here, but hopefully when we look at these, it will make sense when we look at actual problems. All right, so it says consider the exponential function f of x equals 2 to the x power. So this is considered an exponential function because the exponent x is the variable. So your variable is your exponent. Therefore, it's an exponential function. All right, so it says complete the table of values. So f of x, again, is y equals, remember f of x is function notation, so it's the same thing as y equals 2 to the x power. So if we have f of x equals 2 to the x, we can substitute 0, 1, 2, 3, 4. We can substitute any of these values in for x. All right, and then we evaluate. And that gives us our ordered pairs. X's are going to be defined here, so we can go ahead and list all of our X's if we want to. And then all we have to do is find the Y value. And again, to find the Y value, you're just substituting the value of X into the function or the equation. So 2 squared is 4, so my Y value here is 4. 2 to the third power is 2 times 2 times 2, which is 8. And 2 to the fourth power is 2 times 2 times 2 times 2. So that would be 16. And that's how you evaluate for the ordered pairs. Just substitute the x's in to find the y's or your f of x value. All right. It says explain f of x and make the correct selections for these negative values of x. All right, when x equals negative 3, f of negative 3, so f of x equals 2 to the negative 3 power, and that equals 1 over 2 to the third, or 1/8. Remember, we looked at properties of exponents, and this is one of your properties of exponents. This point is graphed at negative 3, 1/8. All right, so when x is negative 2, f of negative 2 equals 2 to the negative 2 power, and that equals 1 over 2 squared. So negative 2, 1 over 2 squared is 1/4. When x equals negative 1, again, they're just picking values of x to plug into your function to make ordered pairs. And by doing that, you're finding your f of x or your y value. So now we need to know what is 1 over 2 to the first power. That's just 1/2. And then that gives us the ordered pair negative 2, 1/4, and negative 1, 1/2. All right, examine how the points are used to generate a graph. All right, the x value chosen in the table are integers. However, based on what you have previously learned, exponential functions are defined for all rational numbers. Rational means can be fractions. Exponential functions are also defined for inputs that are irrational. All right, so it says suppose x equals 4.5. So now this is a rational number because we can write that as a fraction. So it says, what is the value of f of x for 4.5? So what is f of 4.5? So again, we're going to plug 4.5 into the function and see what that gives us. So remember your rules of exponents to help you calculate. If you've got a base, m plus n, okay, that came from two of the same base where you added exponents. All right, so what they're doing is separating this to look at it as 4 as one number plus 1/2 as a separate number because 1/2 is a fraction. So they're doing 2 to the 4th power times 1/2. Half of 4 is 2, remember? And they've got 2 to the 4th is 16. They've already got that part evaluated. And what is 2 to the 1/2 power? All right, so all you're doing is saying that this times this is going to produce what we want here. So they've went through the steps here. They're making it more complicated than it really is. All right, so 2 to the 4th is 16, and 2 to the 1/2 is the same thing as the square root of 2. And 4 times the square root of 2, you can pull up your calculator. All right, if we do 4, actually, we're doing 16 times the square root of 2. So we're going to do 16 times the square root of 2. And that's going to give us 22.62. Now, does it say what to round it to? It does not. So we're going to look at this and see 22.63 would be the closest to that. All right, it says if the domain of f is restricted to only integer values, what statement describes the graph of f? All right, it says the graph would be identical to the blue graph shown. All right, nope. The graph would be a series of unconnected points that would show exponential growth. That's true, because if it's only integer values, there would only be points on the integer values, not on, it wouldn't be a curve connecting all of them. So that one has to be just a graph with dots on it. All right, so which values of x must be in the domain of f to make the graph of f a smooth, continuous function? Okay, so basically they're saying what numbers do we need in order to draw this line and connect the dots and make that smooth, continuous curve. So we basically need all numbers, right? So not just rational, not irrational, but we need all rational and irrational numbers to make that curve. All right, that's all for task 1. If you have any questions, let me know. Lesson 11.1, task 2. Use graphs to analyze characteristics of y equals b to the x power, where b is greater than 1. All right, remember b is your base and x is your exponent, so this is an exponential function. The graph of 3 exponential growth functions are shown. All right, the first one says f of x equals 2 to the x power, and you can see right here, it starts out close to the x-axis and then it grows rapidly as it goes towards positive x. All right, here, very similar, except it's going to grow even quicker, and this is g of x equals 3 to the x. And then the last one is h of x equals 4 to the x, and the same thing, same kind of shape, okay? Exponential functions are all going to have the same general shape, but you can see that the base determines that the larger the base is, the quicker that it's going to grow. All right. All right, so it says, what is the y-intercept for each of the graphs? All right, so for each of the graphs, the y-intercept, if you plug in 0, 2 to the 0 power is 1, 3 to the 0 power is 1, and 4 to the 0 power is 1. So all of these are going to have a y-intercept of 1. All right, does any of the graphs have an x-intercept? Okay, so an x-intercept means they would cross the x-axis. Now it approaches, it looks like it's there, but it's not actually going to touch the x-axis. So none of these will have an x-intercept. So the answer to that is no. It's going to approach it and get very, very, very close to it, but it doesn't actually touch the x-axis. All right, so it says examine the graphs of the exponential growth functions f of x, g of x, h of x. Choose the words to complete the statement about the domain and range of these three exponential functions. All right, so the domain of all three functions is, well, you can see they all go left and right forever, so it would be all real numbers. And the range is everything above the x-axis. So you can see these would be all positive numbers for all three of those graphs. So the range is all positive numbers. And then we're going to look at the end behavior. Okay, so the end behavior, complete the statement to show what happens to the value for each function as the value of x increases without bound. Okay, so that means if it's going to the right. Okay, so when you're looking at the graph, x increase without bound, that means x is going towards positive infinity to the right side of the graph. So as x increases without bound, the value of all three functions approaches infinity. Well, let's see. As x increases without bound, oh, sorry, positive infinity. I don't know what I clicked on, but it's got to go to positive infinity. So you can see all of these, as x goes this way, y goes up. And for all three of the graphs, they're going towards positive infinity. So infinity just means positive or negative. So you have to make sure they are going to positive infinity. All right, complete this statement to show what happens to the value of each value of the value of x decreases without bound. All right, so you can see on all three of these functions that they're getting close to 0, okay? All three of them are getting very close to 0. So as x decreases without bound, the value of all three functions approaches 0. All right, so it says, what is the value of the base, b, for each of the functions, f, g, and h? So the base is your b. So you can see for f it's 2, g is 3, and h is 4. So our bases are 2, 3, and 4. All right, for the function that increases most rapidly, the value of b is 4. Remember we talked about that when we started. The larger base makes it increase more rapidly. All right, isentope. This is a new definition that you need to know. An isentope is a line that a graph gets close to as the value of x increases or decreases without bound. Which statement about the existence of a horizontal isentope for each of these functions is true? All right, all the functions have 1 at y equals 0. All the functions have 1 at 1. All the functions have 1 at x equals 3. None of the functions have a horizontal isentope. Well, if we go back up here and look, we show that each one is approaching 0 here, okay? So that is y equals 0, and that would be our isentope. So all three graphs are approaching 0. All right, that's all for task 2. If you have any questions, please let me know.